Okay, thank you for joining the short observation and data analysis webinar for the ENSO student research campaign for phase 3. This is the February 2018 webinar, and it is going to be live from New Jersey with teacher Ms. Vicki Gorman and her students who are going to be presenting some amazing research they've done. I got a chance to look at their presentation, and it's pretty awesome stuff. So we're super excited to see this. So before we do that, I'm going to share my screen and just go over a couple things and introduce also what when the next sort of webinar will be. So I'm going to share my screen right now, and what you'll see here is, do you see the presenter mode or the regular mode? You good? All right. So what we see here, this one is going to be live from New Jersey, and I should go here. All right. So how does SOTA webinars work? SOTA webinars, as you know, stand for short observation data analysis, where we focus on some of the guiding investigative questions for the campaign. And basically what happens is the students and teachers take measurements using the GLOW protocols that are part of the campaign to help explore one or two or three of the guiding investigative questions from the campaign. And during this, the SOTA webinars, the selected groups will discuss what questions they explored, how they did it, when they collected the data, and how they might collaborate with some other groups. And that's why we have some other folks on as well, because they're interested in collaborating. So hopefully we'll get some good discussion after the presentation. That's the whole purpose of it, to collaborate. And that's one big thing that we're focusing on in this campaign for phase 3. We're focusing on the collaboration aspect of it, because everybody's, majority of the people who are on this campaign really know how to take data and really take data well. And then we take the data and make sense of it. And then we go to the next step. After we make sense of the data, we design research projects and things like that. I say we, I mean students in general, and they're the teachers. And we highlight how we can collaborate with other groups from around the world, other GLOBE schools. And by collaborate, what I mean is that, say they're taking measurements in New Jersey. How do the measurements that are taken in New Jersey, why are they important to other groups from around the world? Why are measurements in New Jersey maybe very valuable to a school in Croatia? Maybe they're taking the same measurements. Of course, they're not in the same location, but maybe they're taking the same measurements, and that's the way you can collaborate. You might be taking information about water chemistry or water quality. So you can look at it in two different locations and do some comparisons. If you take it on the same day, you can do some comparisons. So that's the purpose of this, to really collaborate. So just a reminder, as we go through here, we have some guiding investigative questions as part of the campaign. The first one, what is the quality of water in our environment? We have a couple, suggested protocols. These aren't all the ones that you can do, but these are some of the suggested ones that we've come up with from our team. Second one is, what impact does water both above and below ground have on our environment? And here are some suggested protocols. And this is all up on the website. Let's do a quick reminder here. And the third guiding investigative question is, how does water in our environment impact the living organisms? And here's a list of some of the suggested GLOBE protocols to help explore that question, to take measurements. I want to mention before we go on, here is our next ENSO SOTA webinar. It is on Thursday, March 22nd. It's at 8 p.m. Eastern Daylight Time. And that is, unfortunately, sorry about this, some folks over in Europe, this is 12 a.m. UTC, March 23rd, 2018. And remember, if you can't make it, this will be recorded. So feel free to, if you just can't make it, we'd love to have you here. But if you can't make it, check out the recording. And it's all going to be at the same location at this Zoom address. And this one here is called Transitioning from Data to Action, the Genesis Project. And it's highlighting some work that retired teacher Bob Connick he and I have been talking for several months about some of the work that he has been doing with students in the field by taking globe protocol measurements and then aligning them to some larger scale efforts that are happening in New York as part of the New York watershed. So this is an exciting, this will be an exciting SOTA webinar. I got to see part of the presentation already, and it's really amazing stuff. So hopefully you can join us. We have one of his former students, Emily Pope, will be presenting, who is now a student at Nova Southeastern University, who is taking a lot of the information and measurements and research ideas that she did as a student under Mr. Connick, and working with some of that information in her studies at Nova Southeastern University. So without further ado, we have today, live from New Jersey, as part of this SOTA webinar. This is going to be live from Medford Memorial Middle School in Medford, New Jersey. And students will discuss how do wind speed and wind direction affect the chemistry of rainwater. And the teacher is Ms. Vicki Gorman, and her student presenters are Anna Grockett, and if I pronounce these wrong, excuse me, Anna Grockett, Nikki Dennis, Jalen Rizzo, and Tosca Reeling. And they will be presenting what they did with collecting the measurements using the globe protocols and how they took that data and made sense of that data in order to look at this question: how do wind speed and wind direction affect the chemistry of rainwater? And as you can see, they're looking at the chemistry. So they're looking at, basically, they're looking at the chemistry of the water. So looking at things like water quality, but they're using other variables, which is really cool, of wind speed and wind direction affecting the chemistry of the rainwater. So super excited to hear this, and then we'll do some collaboration afterwards. So I will stop sharing and I will pass it over to Vicki.
Okay, hi guys. Let me share my screen.
Let me stop sharing here.
Oh, I can't, sorry.
Stop. There we go. You should be good now.
Okay. Good deal. Just let me know when you can see the PowerPoint.
Yep, we got it.
Okay, great. And I think I'm going to minimize the pictures, otherwise the girls will be looking at themselves on video, which isn't a bad thing, actually. So welcome, everyone. Thank you so much for taking the time to listen to what my students have to say today. My name is Vicki Gorman, and I have been teaching here at Medford Memorial Middle School in Medford, New Jersey for 10 years. Teaching is my third career. I also have a horse farm, and I'm prior military. So this is, I think I'm finally decided what I want to do when I grow up, which is working with wonderful middle schoolers, ages 12, 13, and 14, and teaching them all about globe and science protocols. So let me, one thing I do have to point out in all fairness, our fourth presenter, which was Tosca Reeling, actually shifted, and I never let Brian know, so it's not his fault, but actually shifted to another research group. So our fourth person now is Hannah Roth, and she has a slide with her photo, and you'll be hearing from her. Tosca, like I said, is in another group. So let me put this on start presentation. Okay.
Looks good.
Okay, do I have to put it on full screen? What happens? Let me try that and see what happens. No, I think
go back. It was better.
Yeah, it was full screen. Okay.
Yeah, this way. Yeah.
All right, great. So without further ado, I am going to hand you off to an able junior scientist presenter.
Hi, my name is Anna. I'm in 8th grade. I'm 13 years old and an artist. And I recently made some sugar muffins this week. And I enjoy working with the GLOBE program because using it really makes you feel like an actual scientist. This is our first transition slide, and I will next be talking about who we are and where we're from. As said before, we're from the state of New Jersey, which is located in the mid-Atlantic to northeast part of the United States. New Jersey has 4 seasons and all terrain such as mountains, rivers, beaches, cities, and even plains. And if you didn't know, New Jersey is known as the Garden State, and it even houses the blueberry capital of the world, which is the town of Hamilton, and they even have an annual blueberry festival once a year. Our state animal is the horse, and yes, we do surprisingly have farms, although if you ever have the chance to drive up the New Jersey Turnpike, you'll mostly just see factories and buildings. And somehow, even with all the farms and buildings and stuff we have, it's somehow the most densely populated state in the US. To put things into a bit more perspective, we are about 20 miles from the city of Philadelphia and 40 miles from the Atlantic Ocean. It takes about 90 minutes for us to drive to New York City, 2.5 hours to drive to Baltimore, and 3 hours to drive to Washington, D.C. We live in Medford Township, which is located in Burlington County, and Medford Township is the largest county in New Jersey in area, and it's the second largest cranberry producer in the U.S. It also has the most acres devoted to farming than any other county in New Jersey, and most of those farms produce sweet corn and fruit. Now on to Medford. It's nestled between fertile farmland and the Federal Pinelands Natural Reserve, which is 1.1 million acres of heavily forested coastal plain. And it's mostly made up of different species of pine, although 35% of the reserve is wetlands and swamp, which makes sense because in the geological past, our part of New Jersey used to be underwater. Now, moving on to our school, as said before, Medford Memorial Middle School. It was founded in 1985, and it currently houses 7th and 8th grade Medford students, and there's about 800 of us. Our mascot is the Panther, and in sports news, just last week, we won the Wrestling County Championship. Go Panthers! We attend school from 7:40 to 2:15 p.m., and the day is split into 7 periods. So for our first period, we have the choice to take a challenge or enrichment class. Enrichment classes are easy, non-graded, and pretty fun. But challenge course classes are hard, rigorous, graded, and slightly hard and stressful. But our class, Csepp, which is a challenge class, is fun. We play hard, we work hard, but we play hard too. And we get to choose our own research projects, and Miss Gorman kind of treats us like little adults. But the question still remains, what exactly is Csepp? Csepp was founded in 2012 by 2 middle school students who wanted to enter the Beneficial Bank School Challenge. So, being the smart students they were, they talked to Miss Gorman about it. They wanted to make a short-term project, but Miss Gorman knew that wouldn't cut it if they really wanted to win, so she suggested something that many generations of students could do. They came up with the idea to have a citizen science education program. They presented this idea to the judges at the contest and took home the first place prize of $5,000. They then used this money to upgrade the automated weather station that is outside of our school and used the rest of the money to jumpstart the program. Our first class of Csepp was then held the next year, school year that is, of 2013 to 2014. And this is now the 5th year and my 2nd year of being in the program. Our motto is students making a difference, improving scientific literacy around the globe. And the program is based on 2 major concepts. Concept number 1 is students improve their own scientific literacy by participating in the GLOBE program and associated campaigns and mimicking the work of professionals. Our second big concept is students conduct science education outreach for the community, applying what is learned in the classroom to the real world. Now, this outreach can be in any form. For the first year we held Csepp, students would travel and teach small groups of about 10 to 50 people. The second class thought to have a science summit where adults and children could come to our location and learn about science that we would teach them. That was a pretty good idea because this is now our 4th year organizing the summit and teaching our citizens about science. And not to brag or anything, but we're pretty proud of our statistics. Over the 5 years of being in action, we've received donations and grants totaling $12,600. And at the end of this year, we'll have educated over 1,000 adults and kids. We've had 100% success. Well, almost. To be a total success, we want other schools to become Csepp schools. Our goal is in 5 years to have at least one Csepp school in every US state, maybe even one in every globe country. Well, that's all for my portion. Thanks for listening. I'll now be handing off to our next speaker, and I'll let her introduce herself.
Thanks, Anna. Hello, everyone. My name is Hannah. I'm in 8th grade, and I'm 13 years old. I'm currently in Csepp because my sister is a Csepp alumna and recommended it to me. I love it. Our next transition takes us to Csepp's involvement in the GLOBE program. Trying new things all the time. First, we took measurements and observations and entered them into the GLOBE databank. Then, we took measurements and observations for various campaigns. Last year, we continued with the data collection, but we also did research for GLOBE's regional SRS, Student Research Symposium. This year, we'll be attending the regional SRS in Buffalo, New York, and some of us will be going to GLOBE GLE, Global Learning Expedition, in Ireland. Next year, we will continue to get more and more involved by doing everything plus the IVSS, International Virtual Science Symposium. Because we piloted the UCAR Globe Weather Unit that lasted till January 2018, unfortunately, we did not have enough time to prepare for this year's IVSS. So what about ENSO? Csepp has been involved since the beginning. Before there was a campaign, we took data for SNAP and GPM satellites. When the campaign began, phase 1 was called El Nino. We collected data and joined the El Nino community. In phase 2, El Nino was changed to ENSO, El Nino Southern Oscillation. We continued to collect data, but we also did research projects. And phase 3, well, that's where we are now. Phase 3 is all about water in our environment. Behind the big topic, there are 3 investigative questions, like on your screen shown. As Cseppers, our group decided to focus on the first 2 questions. What is the quality of water in my environment, and what impacts does water, both above and below ground, have on our environment? We decided to focus on the first 2 questions because we had all the materials to complete that, and the first 2 questions showed more of an interest than the third question. And then there's groundwater. New Jersey is on one of the most prolific aquifers. Look at the yellow. It shows a deep aquifer from New Jersey extending all the way down to Texas. Directly under New Jersey is a shallow aquifer called the Kirkwood-Cohansey. It contains an estimate of 17 trillion gallons of water. Many homes in our area have wells that tap into this aquifer. We have a strong interest in the rainwater that recharges this aquifer and the quality of groundwater that seeps into our soil. Now let's change it up a little bit. It's story time. Csepp's ENSO Phase 3 story. It all started with the GLOBE ENSO campaign. Once upon a time, there was some water vapor. This water vapor condensed and formed clouds. The clouds grew heavy and soon it rained. When the rain hit the ground, some infiltrated the soil. Sometimes the water stayed in the soil for a few days. With all this water, Csepp junior scientists had to be as accurate as possible when collecting data. And they all lived happily ever after. I hope you enjoyed our story. The 6 chapters actually represent the 6 ENSO research projects Csepp is doing this year. Our next speaker will be speaking about the chapters in more depth. And now, to carry on our story.
Hi everyone, I'm Nikki. I'm also in eighth grade and I'm also 13 years old. I'm a soccer player and I actually just came back from Virginia from a regional tournament for state teams and we won our games. I want to be a scientist when I grow up because Globe and Csepp provide amazing opportunities for me. So Hannah explained the general parts of our story, but I want to go into more detail within each chapter. There are 6 chapters to our story. When our Csepp classes were making our groups and thinking about our projects, we wanted projects that were linked together. We answered the first 2 ENSO Phase 3 questions. We wanted a story of water vapor from the atmosphere to the ground. Now, once upon a time, there was some water vapor. Alex and his group found a scientific paper on GPM satellite data that showed water vapor rivers in the atmosphere. Now, you might be wondering what water vapor rivers in the atmosphere are. They're simply atmospheric rivers. Atmospheric rivers are narrow stretches of water vapor in the sky, just like a river except with water vapor. They transfer the majority of water vapor from the locations outside the tropics. They always move with weather, which in the US is from west to east. And something interesting to note is that an atmospheric river has the amount of water vapor equivalent to the average flow of water at the mouth of the Mississippi River. When water vapor condenses, it forms clouds, and the precipitation usually falls as rain or snow. In the US, the atmospheric rivers comes from the Pacific Ocean or the Gulf of Mexico. After learning about all of this, Alex and his group research question became, how do atmospheric rivers affect the amount of precipitation in our area? Now, to continue with the story, the water condensed and formed clouds. Maggie and her team are going to try to use cloud observations to predict the weather. They will be taking observations 2 times a day. In addition, they will be keeping track of air pressure. They will only use the air pressure data if they find that their observations are accurate enough with just cloud observations. They're planning to make a pamphlet on how to read cloud observations for the public. They also want to talk to elementary school students about how to observe clouds. They will be using the Globe Cloud Observer app and SatCam to record data. So next is Chapter 3, Precipitation, but we're skipping that for now. Now is Chapter 4. But first, let's review. We started with water vapor in atmospheric rivers. The water vapor condensed to form clouds, which Maggie and her group are using to predict weather. Then it starts to rain, but we're coming back to that later. Now some of that rain infiltrates the soil. Some of that rain may be affected by the pH of the soil. Danny's team will collect 90 samples from 30 different sites and test the effect of the soil sample's pH on water. Moving on to Chapter 5, which is sometimes the water stayed in the soil for a few days. Owen's team corresponded with NASA and MIT scientists to get some insight on their research with soil moisture memory and data from Csepp. In the article that Owen and his team read, the scientists were surprised with the 5-day moisture memory of the soil after a rain event. The scientists were supportive of Owen and his team and suggested that Owen and his team should test the drying rates of different soil as well. Last chapter deals with getting the most accurate data we can as junior scientists. Last year at the regional SRS, one Csepp team did research on how well they were helping the SMAP scientists with their soil measurements. They found that their gravimetric data was consistent with the SMAP satellite data, but their volumetric was not. They believed there were too many variables when using a dentable can to collect samples. They suggested that a new protocol be tried this year, so that is what Tosca and her team will be doing for their project. Now we can go back to Chapter 3. Woohoo! We saved the best for last. The clouds grew heavy and soon it rained. Our chapter of the story is rainwater and the chemistry of that rainwater. And now to take you through our chapter of the story is our last speaker. Thank you for your time. Hi, everybody. I'm Jalen. I'm also 13 years old and in 8th grade. Another soccer player here. In fact, Nikki and I are on the same club team. I feel very lucky I'm able to do actual research, and I really appreciate the opportunity to collaborate with other students. In fact, by other students, I mean fellow Cseppers from Medford Memorial and hopefully new Cseppers from other schools. Like Nikki said, here's Chapter 3, our team's research. Rainwater. We knew we wanted to combine rainwater with our location, in between a major city and a major ocean. Wind direction. We knew that the east winds would bring chemicals from the ocean, and the west winds would bring pollution from Philadelphia. Because of our unique location, we felt as though wind direction might have something to do with rainwater chemistry. After we came up with our idea, Ms. Gorman asked, have you collected enough information to decide if you're on the right track with your research proposal? So we went online and found a research project that had been conducted by 2 universities, University of North Carolina, UNC, and Elon University, which is also found in North Carolina. The scientists and the students studied the dynamics of chemical composition of rainwater throughout Hurricane Irene. They already knew that extreme weather events that include heavy rain and high winds can result in significant deposits from the rain of different chemicals over short periods of time, resulting in a significant impact on the biogeochemistry of the receiving watersheds. The North Carolina teams collected samples of rainwater throughout the duration of Hurricane Irene in Wilmington, North Carolina, USA, on the 26th and 27th of August in 2011. 11 of those samples were analyzed for pH, major ions, dissolved organic carbon, or DOC, and hydrogen peroxide, H2O2. The samples collected early in the storm, when winds blew out of the east, contained dissolved components of marine sources, like sea salt from sea spray and low DOC. The sea salt components in the samples had a maximum in concentration during the storm, which occurred before the volume of rain had sufficiently washed out sea salt from the atmosphere. As the storm progressed and winds shifted to a westerly direction, the chemical composition of the rainwater became like characteristics of storms that form over land, high DOC and low sea salt. We thought maybe our research question would work, but did we have enough education and the proper equipment to measure data and understand the results? We felt we needed to contact one of the lead scientists from the Hurricane Irene research project. So we emailed Dr. Catherine Mallow. She was super helpful. Here were her suggestions. As a red light, she suggested not to check dissolved oxygen because rain is pretty much saturated with oxygen all the time. She said hydrogen peroxide is extremely hard to measure, so that was a no-go. She also mentioned that rainwater is usually low in salinity. Now notice the asterisk by salinity. I'll explain that in a minute. Now on to the possibles. We would need special instruments to test for dissolved organic carbon. Though Dr. Malal suggested we could try to find a university with the equipment, we decided not to link up with a local college this year, but we already suggested this collaboration for next year's Cseppers. Testing for cations and anions would require new equipment, so we decided against that, although this also is something we will recommend to future Csepp classes. pH is a definite green light, as are nitrates, and even though Dr. Malal said salinity might be difficult, we are still interested in checking out the rain when there is an east wind. We realize testing with a salinity kit might not give us good results, but that's all we have for this year. Maybe future Cseppers will be able to get the equipment to test for ions, especially sodium and chlorine. So you all may be wondering, what do we decide for our final research question? Well, there are actually 2. One is having to deal with wind direction and speed. How do wind direction and speed affect the pH and salinity of rainwater? Nitrates is something we do if we have time. The second concerns the amount and rate of rain. How do the amount of rain and rate of rain in a single rain event affect the pH of rainwater? Because we have a two-part research question, we have more than one hypothesis. The first one is that if there is an east wind, the salinity of the rainwater will be higher because the air is coming from the ocean. The second one is if there is a west wind, then pH will be lower and nitrates will be higher because there's pollution in the air coming from Philadelphia. Hypotheses 1 and 2 require specific wind directions. We don't know if we will have enough rain events with those parameters. To move on, here's hypothesis 3. If there is a lot of rain, the pH will rise from the start to the end of the event because the acid in the rain will become diluted. Hypothesis 3 will be the easiest to check and the one on which we will concentrate. Now moving on to the protocols and materials. Checking the weather report. We will be checking the weather report from various sources to identify future rain events, general direction of storm movement, and the predicted amounts of precipitation. We know that we will use rain gauges and/or clean glass or plastic sampling jars or bottles with lids. Sites will be our school and sometimes our homes. We know that in Globe, you must have a registered site and input specific data from that site. But our research does not fit perfectly with any one Globe protocol. So in the evenings and/or on the weekends, some rainwater collection will be conducted at our homes. We all live within 5 miles of the school, and for what we are testing, we don't think the difference in sites will make a difference in our findings. Next off is rain samples. The rain sampling depends on the type of the event. A light rain, a heavy rain, a major storm, like a nor'easter. At a minimum, samples will be taken at the beginning, middle, and end of the event. Sometimes, hourly samples. In some cases, samples will only be taken if there is a significant shift in wind direction and/or speed. We will be finding the chemistry of water using the pH paper, a pH meter, a salinity kit, and a nitrate kit. And finally, we know our project should involve input into the Globe data bank, but again, our protocols do not fit exactly with Globe data entry. So, we are going to help one of the other research teams by checking our school rain gauge and when there is enough water, testing pH. We will be using a mobile weather app on our phones that's tied to our automated weather station to check the current conditions of the weather. Not only will we check the things measured by our weather station, but we will also use the radar images and the lightning monitor so we can keep safe during the rain event because we can get some strong spring storms here in New Jersey. So we understand the point of a SOTA webinar is to relay our findings of our month of research, but our start date based on the time it took to collect information, correspond with our scientists, and gather our materials is tomorrow, March 1st. We're lucky because tomorrow and Friday we're expecting moderate rainfall, and guess what? It's a nor'easter. How lucky is that? Strong winds will begin out of the east and northeast, and at the end of the storm, they will be ending out of the north and northwest. To recap, 1, we really would want your school to become a Csepp school. 2, we would love to work with your school to compare data about rainwater chemistry. And lastly, your school could work with any other Csepp team on their project. This is what we'd like our Csepp map to look like next year, with Csepp schools across the U.S. and the world. On behalf of Anna, Hannah, Nikki, myself, and Ms. Gorman, thank you for giving us this wonderful opportunity to present to you. If you want to join Csepp or collaborate with us on our project, or collaborate with our fellow junior scientists on their projects, or if you have any questions not answered today, please contact Mrs. Vicki Gorman at vgorman@medford.k12.nj.us. Come on, guys. Thanks again.
Okay, let's turn on the sound. Okay, you guys, I'm going to stop sharing.
Thank you
Okay.
so much for that presentation. That was amazing. And we're really looking forward to, the data that you get further and how you answer those hypotheses. So we're super excited. Instead of me talking, does anybody here on the webinar have any questions, comments, or ideas from listening to the presentation? And feel free to unmute your phone and ask. Everybody's so quiet.
Oh, can I add something?
Yeah.
Hi, everybody. I'm Jalen. We will be taking our research in a total of 1 month or
6 weeks.
6 weeks. Sorry, not 1 month. 2 months.
Yeah, I really like the metaphor you said for soccer to science. It's important to play the game. I think that's really interesting. I like the way you think.
Now you guys are going to have to own that, since you're champion soccer players and you're champion scientists, but you are also absolutely phenomenal presenters. I found myself totally spellbound by your slides, by your story, by your research. And I would love to send your teacher the link and some ideas I have for having you guys submit just a paragraph giving some information on what you did to the H2U project, because that is just what you have worked on is phenomenal. And it's just like I say, one paragraph, but your teacher will show you, it will put you on the map, and then you can also show it to your friends and family and soccer coach and say, hey, here's our research, put on the map, and here's where you can access it. So really, really cool.
Okay.
Wow, thank you so much.
I really
Thank
appreciate
you,
it.
Brian. Awesome. You
Yeah.
rock.
I just popped in the H2U project website in the chat section. It's just h2youproject.com. And it's already mentioned that it's all about water stories from around the planet. And you can check, wherever they are, they're just about everywhere. So you can click on it and learn about what's happening water related in any part of the world. And, I'm sure based upon the presentation you gave today, that people want to read a little bit more about that. And super excited to, we'd love to get your group, the Csepp group, to build, because we think that you have really great structure there and a really great organization. And I think that's amazing. Have you gotten Jeff Bauman in there yet?
Well, I've talked to Jeff. Oh, hang on. I'm getting feedback from my. I've talked to Jeff about it, of course, and he's one prime candidate that would be perfect for a Csepp school. Mr. Science. Wait, what is it? Just do it, or science?
Getting science.
Yeah, get it done. That's right. Get it done. But yeah, he's one of them, and there's a lot of other teachers out there too. And we have a video that the Cseppers made last year. That's a PR video that explains how to become a Csepp school, and it's really easy because basically it's the two concepts. Number one, you have to be a globe school and do some sort of globe research so your students become better junior scientists. And the second thing is you have to do some sort of education outreach. And it doesn't have to be as extensive as we do it. We have a website that's being built now, and you'll be able to use our logo free of charge and be able to populate the site with all your projects. And I just put in, as a matter of fact, my proposal to talk about Csepp at the GLE in Ireland. I don't know if I'll be picked, but I'd love to have that as an audience.
Yeah.
Vicki, I was thinking about this with the students, but this also is true about the program you've set up. As you know, imitation is the sincerest form of flattery. And I was thinking that's in part why I want the kids to share what they have on the H2U, but also why I think it's so important that you guys reach forward, like at the GLE and in so many other contexts, and share what you have been able to create, because having a class like that, that's an elective class, but you know, very, very challenging as well, and to be doing real world citizen science is a huge model. And then watching the way that your students presented with those 6 overall focal areas that they were looking at, and telling the story from the atmospheric rivers, and you know, the way that they separated it into those ways of looking at it, I just think is another thing that is a model that should be imitated, because it is such an effective way of telling the story and also helping them know what is the data that's important. I was so blown away, and I really do hope that you take what you have done and your students take what they're doing and share the story, which is also what Brian's doing, you know, here and now as well, is amplifying this, because your work is phenomenal. Thanks so much for making time to share it.
Thanks, Dorian. We really appreciate it.
Yeah, the way you explored the questions by answering, no, I shouldn't say it. The way you explored the questions by looking at other questions in order to explore those questions is really awesome, because it really takes it to the next level of depth in understanding the data that's going to be taken. Mm-hmm. You know, when we can all take data, you know, we can get soil moisture data. We can say, great, you know, we have so much water in that soil. Okay, let's take the next day. We got so much water in the soil. But then you can ask questions about, why is that water in the soil for so long? Why is the infiltration rate like that? You know, what type of soil is this is one thing, but understanding how the water moves through the soil based on soil, you know, grain size and soil type, that's so important to go to that next question. That's why we have those guiding investigative questions, to help explore that. And as we said many times during this phase of the campaign, you know, when the questions are being explored, the sky is the limit. You can take as many protocol measurements as you want. You can answer as many, you know, sub-questions as you want. But as long as it gets back to exploring those guiding investigative questions, which you guys, you know, at Medford did an amazing job doing that. And you're just beginning on your research, you know, for this project. And, you know, you have such an amazing structure that I think it serves as a good model for other schools to do that. And I know some of the teachers that are online now, I see some folks from Croatia and the United States. I see Richard in Puerto Rico. So yeah. So, and I know that a lot of schools in Croatia really like to collaborate with others. We have several collaborating based upon a presentation from Croatia during the last SOTA webinar, which that would have been in December. We didn't have one in January because of lots of breaks in the United States, lots of breaks, so there weren't a lot of measurements taken during several weeks. But yeah, you know, we have to keep these collaboration lines open. So we're super excited about this, and I know some people besides myself may want to say something. So anybody else have any thoughts about it?
Brian, this is Svetlana from California. I just have a quick question. This was so impressive. Thank you so much. I wanted to know if we wanted to share this webinar with others. I know you're recording it. What's the best way to find it after it's archived? Will it be on the Globe website?
Yeah, it'll be on the Globe website. After recording stops, then it has to process through Zoom. I get sent a link, and then what I'll do is I'll take the actual video and put it up on the. It'll probably be a link to. I'll probably put it on YouTube because that's the fastest, and then it's a direct YouTube link you can just grab, because it takes a little more processing time to put the huge thing on the Globe website. So it's easier to put it on put it as a YouTube link through. But I will send the direct link. That is, it's the webinar page for phase 3. So, but I'll send that link directly out once I get the recording, once I get it up on the Globe website.
Perfect.
And yeah, feel free to share that with everybody.
We will.
Thank you. Anybody else? So yeah, in the comments, I did put Ms. Gorman's email address to contact her. That's vgorman@medford.k12.nj.us. And then I also put the H2U project. So yeah, feel free to contact. Well, I'll let her speak for it, but I'll say feel free to contact. Since it was in the slide, feel free to contact Vicki. All right. If there's nothing else, I just want to say thank you so much to Vicki and her students for presenting. This was amazing stuff, and we're super excited that that the research that they're doing is so involved in, but yet we can see the passion from the students, you know, for the project. So super excited, and the creativity in the presentation was wonderful as well. So anybody else have any parting thoughts?
I just want to say thank you for giving my students the opportunity to do this. I can remember several years ago, in the not too distant past, I didn't even know what a webinar was. And since then, I've done lots of webinars myself, but for 13-year-old young ladies to have an opportunity to participate in something like this, of this magnitude, and for those of you joining from other countries, thank you, because I know the time difference can sometimes be a little bit of a hassle, but this is an amazing opportunity they won't soon forget. And so thanks, Brian, thanks, Dorian, and thanks to everybody who attended.
Okay, thank you so much. So with that, we can adjourn, and once again, thank you so much. Oh, I did see Kevin has a nice comment here. One of my undergraduate students used your data from Medford for a class project on urban heat island effect last week. So very cool.
That's cool, Kevin. Thanks.
Oh, thank you.
Hi, Timmy.
Yeah.
All right, thank you. I will stop the recording now.